these are going to become inequalities whenever we have, instead of having a less equal sign, we've got either a less than, greater than, less than or equal to, greater than or equal to. Okay? So, let's start. I always like to start with like the absolute simplest type of question I could ask you. Okay? So, and all of our answers on these, we are going to put those on a number line. It also helps us like write down our answer whenever we do that. We're going to graph the answers to absolute value of x is less than 3 on the number line. So I want you to, on this number line, you're going to highlight all the numbers that would work for this. Like, for example, if I plug in 0, is it going to work? Would 0, absolute value of 0, be less than 3? Yes, absolute value of 0 is less than 3. So 0 should be in like your shaded region. Okay, so shade all of the parts that could make that true. All the numbers that your absolute value is going to be less than 3. Okay. What numbers should I include? Okay, 1 is definitely on there. Let me get my highlighter out here. Oh, gracious me. Not that. All right. 1 is definitely included. 2 is included. What about the numbers between 1 and 2? They're on there too, right? What else? 0 is good. And anything in between there. -1, -2 are okay. -6? Oh, the whole thing? No, that would be the case, because if I plugged in, like, if I did plug in -6, what's the absolute value of -6? It is 6. Is 6 less than 3? No. So, I can't go, Carlos, he highlighted his all the way down, everything below, over here. Can I go all the way down here? Where have I got to stop? Okay, I'm hearing -3 and -2.
In between the 3 and the 2.
Okay, I can go in between the 3 and the 2. What about at -3? How could I show that I don't really want -3? Not an X, no. Circle that's hollow in the middle, right? Open circle right there. That shows I want to go all the way to -3, but I'm not counting -3 because it wouldn't be true, right? All right, so on the other side, I'm going to do the same thing. I'm going to highlight all the way up here. I'm going to put an open circle right here at 3. So all the numbers between -3 and 3 make this true, right? If I put in -2.5, when I take the absolute value, it becomes positive. 2.5 is less than 3, right? So all of these in between are true. We can think about this as these are the numbers that are less than 3 units away from our 0, right? Because 0 is right here. My absolute value, we can think about it as our distance from 0. So it's everything that's less than 3 units away from 0. So I could go 3 to the right, 3 to the left of 0, and there's my cutoffs. Okay.
So basically, any number that it is, so like if it was a different number, it would be like all the way to -4 or 2 because those are the only things to get.
Yes, yes. And it's really important here. This is for less than problems, We're going to see something different if we have greater than. But if we're doing a less than problem, what happens is these are what I call and problems. Okay? You are looking for what makes both of these statements true. So we are looking for everything. We'll see when we do this problem kind of why I'm saying and instead of or right there. And what should happen most of the time is you're going to get answers that fall like between two numbers. Like it's going to be in between maybe -2 and 7, or -5 and 5, or 10 and 20. Right? It's usually between numbers most of the time for these problems. So let's do one of these problems. Just like with our problems where we had our absolute value equations, we have to have the absolute value bars by themselves first. So that's no different, right? So for this, whenever I'm looking at this Sailor, I've got my absolute value bars here. I need to get rid of that 2 that is on the outside. How would I get rid of that? I cannot add it right there because that 2 is right up next to the bar. So I'm going to divide. Right? And so that's going to give me absolute value of x minus 3 is less than 4. Okay, so here's what you will do. Just like with our equations, we have to do a 4 and a -4 here. But there's going to be a trick to the second one. Okay? So the first equation we're going to write, we just drop the bars basically. X minus 3 is less than 4. Nothing changes. We just don't write the bars. Right? On the second one, we're going to have x minus 3, and we want to change this to a -4. But this is really important here. We've got to flip the sign. Okay? So notice how I had a less than. This sign right here, we're going to flip the inequality sign. If we go back up here and think about this, think about it this way. These numbers I have right here, they're the numbers where x is less than 3, right? But it's not the unnumbers x less than -3, right? Because we didn't highlight anything below -3, right? It's the numbers less than 3, but that are also greater than -3. So whenever you're doing inequalities, it's pretty much the same, but you got to flip that second sign. With equals, it didn't matter because there was no sign to flip. Equals is just equals, right? But with inequalities, we got to flip that second sign. So then we're going to solve. So let's see. William, tell me how to solve this one. Right here, x minus 3 is less than 4. Perfect. So x is less than what? Y'all be quiet and give them some time to think, okay? All right. Y'all quit. Y'all quit. Because y'all going to make it where nobody wants to answer because they're going to get picked on in here. And trust me, we're all going to make mistakes, myself included. So, and sometimes you just need a minute to think about it. But whenever you got somebody looking at you, staring at you, intimidating you, sometimes you get messed up. All right. So, let's see. Anissa, what do I do on the second one? Add that 3. And so x is greater than, what am I going to get for that one? -4 plus 3. Perfect. Okay. All right. Now, the trick on this is you can't write your answers like this. It's not going to let you put your answers in this way. So I said these were and problems. That means that you're looking for what makes both of these statements true. So if I put this on a number line, I've got a -1 and a 7. I really don't need the stuff in between, you can put tick marks there if you want, but these are my key points, right? And so if I graph the numbers that are less than 7, I could do an open circle here, and I would shade below. And I'm going to graph the numbers that are greater than -1, and I would shade above. Let me use a different color for that, actually. Let me use different colors for both of those. So 7, shade below. So the black is for the 7, the pink is for the 1. And I have shaded the whole entire number line. But I'm looking for the numbers that make both of these true, right? So I'm looking for where these overlap, where both of the graphs are, because it can't be either or, it's both of them. So what I'm looking for is this part here in the middle where my graph overlaps, right? And that happens from -1 up to 7, right? So the way that we are going to write in between answers is we are going to put our lowest number first, -1. We will always use less than signs, okay? Always. Even though it was a greater up here, don't worry about that. Always use less than signs. -1 is less than x less than 7. I'm not going to put or equal to signs with either one of those because I didn't have an or equal to sign in the problem. If I had an or equal to here, I would put or equal to's here, but I did not. So, but you always either use the less than or the less than or equal to. This is your answer. It tells you that you have all the numbers from -1 up to 7. You're not including -1 and 7.
So the both signs have to go directly to the highest number?
The alligator, yeah, like your alligator is eating that highest number. Both of your alligators are going to be eating that highest number. That's a good way to think about it. All right. And really, if you think about like what happened here too, like you had that x less than 7, that's still there, right? And here you had x is greater than -1, but you flipped it around. You put the -1 first. If you put the -1 first, you got to flip the equal sign because this alligator right here, he always wants to eat the x. So when you write him over here, he's got to be eating the x, right? And this alligator wants to eat the 7. So when you write him down here, it's got to eat the 7.
So when you have the biggest number, the alligator has to eat the biggest number. But like for the first one, does it matter what signs, or do you have to put the number before the x?
The best way to think about this really is to think about what your graph looks like. Like if we went up here and wonder, I didn't really write my answer for this one. So if we just want the numbers from -3 up to 3. So the best way to really think about it is just that you're going to write your lowest number first, which is going to be, in this case, -3. You are going to always use less than signs. I'm not going to put or equal to because I didn't have or equal to here. X always goes in the middle. Always use a less than sign. Always put your highest number first, last, which is that 3. So if you just always do lowest, less than, x, less than, highest, and it's in between, then you should have that right. Okay. All right. Questions? All right. Let's look at what it's going to look like if we have a greater than sign, because things are a little different if you have a greater than sign. Okay, I've got you another number line there. I need you to highlight or color in on that number line all the numbers where the absolute value of x is greater than 3. So instead of being less than 3, this time they're greater than 3. As I walk around. So this time it's not going to be the middle part, is it? This time, what you should have highlighted is you're going to have an open circle here on 3, and it's going to be all the numbers bigger than 3. And then you'll have an open circle here on -3, And it's going to be all of those numbers lower than negative 3. Right? Because if I plug in negative 4, it becomes positive 4 is greater than 3. If I plug in positive 6, absolute value of 6 is 6, 6 is greater than 3. Right? So notice here, our numbers are not in between. They're on the ends. Okay? These problems, greater than problems, we want to think about this as these are the numbers that are more than or greater than 3 units away from 0. So, because it's a greater than problem, we're talking about, right here 0, that's 3 units, that's 3 units. These are further away than 3 from our 0. Okay? Now, these problems, our greater than problems, are OR problems. They do not overlap in the middle like we saw in the last problem. Usually, if they do overlap, it's going to be all real numbers. It's going to be your answer. Usually, they do not overlap. And you're not going to see those exceptions very often. So, we are looking for what makes either statement true. It does make it a little easier to write your answer on these. So, where's my problem there? Why is it gone? Did I not put a problem there? I don't guess I did. I can make one up. I'm a professional at this. Let's make one up since I didn't put a problem there. Let's see. Let's do absolute value. Oh, I know what we need to do. Let's see if you guys remember this. All right, let's do absolute value. Why is it not on there right? Okay, absolute value of 7 minus x over negative 2 is less than it does not. There's a trick. I'm trying to see if you remember this. There's a trick to this one. Is less than negative 3. Alright, so I'm throwing a trick in here because I can't remember if I put it later in the notes, so I want to do it right now because it's going to be something you might run into. Alright, I did, Aiden's like, Miss Hyatt, you've lost your mind. Okay, what am I doing? Why did I do that? What's the first thing I'm going to have to do? I'm going to have to multiply by negative 2. That negative 2 on top will cancel this negative 2 on bottom. I'll multiply by negative 2 over here. And I'm making you do this because if you multiply or divide by a negative number for this problem, you have to flip the inequality sign. So this one looked like it was a less than problem, but when we do this, we get absolute value of 7 minus x. Oh, wait, hold on. No, it's okay. I'm going to leave it like that. Is greater than 6. Everybody okay there? All right, so just like we did on the last problem, we're going to split this up. We're going to have 7 minus x is greater than 6. Just basically drop the bars. And on the second one, we're going to have 7 minus x is less than negative 6. All right, so KT, how do I solve that first one? You could move the x, but in general, we kind of want to keep it where it's at and solve, like, get rid of the other stuff. So I need to get rid of that 7 first. How would I get rid of it? I'm going to subtract, because it's a positive 7, right? So I need to subtract 7. And so that does not get rid of the negative. I still have a negative x greater than, and 6 minus 7 is going to give me negative 1. Alright, now that negative right there is like having a negative 1 times x. So, Passion, how do I get rid of that negative 1? Actually, technically that can be correct in this case. It can be correct to multiply. What would you others of you say? Can't add. We cannot add because that negative 1 is right next to the x. Right? When they're right next to each other, they are multiplying. Right? Right next to each other, they're multiplying. So we have to divide is what I would say. It actually works either way for this one because it's negative 1 is the only time this works. Because negative 1 times negative 1 would also be 1, which would kind of make it go away. So you could kind of like multiply. Basically, you're multiply, divide, either way you want to think of it for this one. You get x, and you get 1 over here. And what did I just do? I divided by a negative again. So I got to flip that sign. It was greater than, now it's less than. I hope I didn't make a bad problem here. I may have. There's a chance. There's a chance. Okay. There's a chance. It's a bad problem. Okay. Alright, so, but we got an answer. Alright. Second one. Wait, what would we do? Yes. Yep. Okay, then? So x is greater than 13. No, we're okay. This is going to be beautiful. Things are going to happen like I want to. Okay. So, the good thing about this problem, if it's greater, that's an or problem. A lot of times whenever you kind of say greater, you can kind of say it like greater than. It's got or in it. Less than. If you want to kind of think of and, less than. It's not exactly right, but it might help you a little bit. So this is an or problem. So what's happening on this, if we graph this, we've got a 1 right here. We got a 13 here. And we're doing all the numbers less than 1 and all the numbers greater than 13. There is no way, we're not writing numbers in between. So we don't have to do anything fancy with this. We would just say x is less than 1 or x is greater than 13. Right? You can just use the word or for that because you can't put those together. If you try, you're going to end up having like the numbers in between 1 and 13, which is not what we want here. You okay there? Okay. Most of the time, greater than problems look like this. Most of the time. Alright. So, let's just do some problems. Okay. Alright, let's do absolute value of 2x plus 3 is less than 6. This one is already absolute value bars by themselves, right? We're just going to break it up. So the first one will look like this. 2x plus 3 is less than 6. Second one is going to be 2x plus 3 greater than negative 6. And so we need to solve each one of these. Let's see. Ayla, how do I solve that first one? Good. Good. And then, oh, what do I do with 3 divided by 2? You just leave it, or you can make it 1.5 if you want. Either one is fine. Okay. Passion, how do I solve the second one? Very good. Oh, do I? It feels like maybe I should, but maybe I shouldn't. Okay, did I divide by a negative number? No. It's the number on top that is, so the number I'm dividing by is positive. So I'm not going to flip the sign here. But I'm almost glad that you did that because it feels like you should flip it because you see that negative. But only if the number on the bottom, the number you're dividing by, is negative. So we would not have to flip on that one. Okay, oh, I didn't even think, is this a and problem or an or problem? It is a less than, right? So this is an and problem. So we are looking for what makes both of these true, which means if we graph them, we got to see where they overlap. Now, probably it's negative 9/2 less than x less than 3/2. Probably with numbers between negative 9/2 and 3. But I like to graph it to be sure because there are some exceptions to that. So negative 9/2 would be here and 3/2 would be here. We are looking at, let's use pink for the 3/2. We're looking at the numbers less than 3/2. And I'm going to use yellow for my 9/2. We're looking at the numbers greater than negative 9/2. Where do I overlap? The middle. Yes. If this is a less than, not tan. If it is less than, then it's an and problem. Once you get the absolute value bars by themselves. If you have a less than, it's an and problem. You're looking for where they overlap. It's usually going to be in between two numbers. Think about what we did at very first. The distance is less than 3 from 0. So that's like the numbers in the middle close to 0. Versus greater, the numbers greater than 3 away from 0. Those are out there on the ends, right? So less than is going to be an and for that. How do I write this as my answer? Anybody want to try? What do you think, Katie? Good. Yeah, that will be your answer. So whenever you got in-between ones and problems is where this is going to happen. You're going to put your lowest number, less than x, less than highest number. Hopefully I did put some on here that have or equal to. So if not, I'll add one on one of these next ones. Okay? Questions? All right, let's keep going so you guys can have some time to do your work here. All right, this one, and or problem. Or. And I know that because this is a greater than problem. Right? Greater than. So, as far as how I work the problem, it doesn't change much. It just changes what's it matters for what my answer looks like. So I've got 2x minus 3 is greater than 5, or 2x minus 3 is less than negative 5. Okay, Carlos, how do I solve this first one? Good. Gives me 2x greater than 8. What do I do next? Good. And I'll get x is greater than 4 for that part. The second part is basically the same. You're just going to get different numbers, right? Add 3. 2x is less than negative 2. Divide. What do I get? Good. Oh, was I supposed to flip the sign there? No, because I'm dividing by a positive number, right? All right, so if I graph that, let's put negative 1 down here. Let's put 4 up here. We're looking at the numbers less than negative 1 the number is greater than positive 4. This is just, things on the end. OR problems normally look like this. And so I can't write those together because we're not talking about the numbers in between. So we would just say x is less than negative 1 or x is greater than 4. You might see that you could use that U that we used for some of like our interval notation instead of using the word or also there. Okay, questions? So where are we at? How much more we got? A little bit. Okay. All right. Okay, there are some special cases that are going to happen here. So as I was telling you, I said that a normal case, let's think about a normal case first. Normal, if I have a less than, which is a and problem, then whenever you graph it, you got like in between 2, right? We got in between. And if I've got a greater than, which is an or problem, I usually have ones that go away from each other, right? That's the normal case. That's what the majority of your problems are going to look like. But there are some times that you get special cases. So let's look at what happens with those. So I've got absolute value of x plus 2 is less than negative 1. All right, let's solve that one. So I would have x plus 2 is less than negative 1, and I would have x plus 2 is greater than positive 1. Is that an and or an or problem? I look right here, it's less than, so this is an and. So both of these have to be true, it has to overlap, right? So if I solve these, I got a negative 2. So I got x is less than negative 3. And if I solve this over here, I would subtract 2. X is greater than negative 1. So if I graph those, right here, oh wait, that's wrong. That's positive 1. I got x is less than negative 3. So negative 3 is right here. So the number's less than negative 3. And I've got x is greater than negative 1. That's the numbers right here. Where do those overlap? Nowhere. And this is supposed to be an and problem. But does it look like an and problem? No. So these do not overlap anywhere. That means there's no number that makes this true. So this is a no solution. Okay? Now, we should have been able to catch this from the very beginning if we really thought about it. Now, a lot of times you won't. A lot of times you have to go through the whole problem because you forget to look for this. There is something about that problem from the very beginning that should let us know, oh, that can't happen. We got negative 1, and we are less than negative 1. Can absolute value ever be less than negative 1? All those numbers are negative, right? And so if less than negative 1, if you have less than a negative, it's always going to be no solution. So if I gave you a problem like this, x plus 7 is less than negative 5, what could you write automatically? That's a no solution. Because you can't be less than a negative number. So be on the lookout for that. It may happen. It's not going to happen a lot, but it might happen. All right, let's look at the other special case. I've got absolute value of x minus 2 is greater than negative 3. So we'll solve it. X minus 2 is greater than negative 3, and x minus 2 is less than positive 3. Is this an and or problem? We got greater is an or. That's an or problem, right? So we would expect it to look like this, but it's not going to happen. Alright, so if I add 2, I would get x is greater than negative 1. And if I add 2 here, I get x is less than 5. So if I graph it, I would have my 5 up here, and I would graph everything less than 5. And then I'd have negative 1 right here, and I'd graph everything above negative 1. But this is an OR problem. You don't have to have overlap on this one, right? Either one of these could be true. So we have highlighted the whole entire number line, right? The whole thing is shaded one way or the other. So this would be all real numbers. It's possible, I think you're going to see all real numbers. It's possible you might see infinitely many solutions on something. I'm going to throw that out there. You might. I think you're going to see all real numbers instead. But no, those can kind of, they go hand in hand. So, in general, if you see a less than a negative is an and problem that looks like an or whenever you graph it. If that happens, you got no solution. And this is going to be an or problem that looks like an and problem. Right, so you got a or problem that it's actually overlapping. That's going to be all real numbers every time. And if you think about it, you got absolute value greater than a negative number. When you take the absolute value of something, it makes it positive, right? And a positive is always greater than the negative number. So anything could make this true. Right here is what it's saying. So you may run into these. You're not going to see them a lot, but you may run into these occasionally. The majority of the problems are going to look like the others that we've done. All right. I want you guys to try these on your own. The only thing that's going to be different whenever you got the line under the symbol is that whenever you would have an open circle, you're going to have a closed circle. And in your answers, like your answers will have or equal to's underneath them. So it's the only difference that you'll see there is that, like, if you have a less than sign in the beginning, you should have, either a less than or greater than in your answer. If you have a less than or equal to, you're going to have a less than or equal to in your answer. So this one is not right beside the X, so you would look at that. If it was just 5 times 5 beside the X, then I'll be right there.